Hi, everybody. Thanks for the introduction. So, yeah, my name's Jeff Avery. I'm one of many researchers on this project. This is actually work that was done last year over the summer as a collaboration between the University of Waterloo, INRIA, and Université de Lille. So, the motivation for our work really is the shift that we've seen in the last decade or so from sort of desktop computing and notebook computing towards primarily small, portable, personal computing devices. I think you're all aware of this. There's a lot of research that's gone on around this. But this represents a major shift in the way we actually use technology. So for many people, it's changed so that smartphones, tablets are actually primary computing devices now. And this has changed the way that people use devices. You know, it used to be that keyboards were super important for us, and they're certainly still important, but along with the shift in computing devices, there's a shift in input modalities as well. So multi-touch in particular has become the sort of dominant form of interaction for a lot of people that rely upon these devices. But despite the success of multi-touch and the success of these devices, there hasn't actually been a lot of research done on sort of the basic canonical gestures and how we leverage multi-touch on these devices. So that's really what our research is focusing on, is sort of optimization of some basic gestures. And what we're going to talk about today is pinch to zoom, primarily in pan, which are two sort of associated gestures that work together. And you often see pinch to zoom in these types of tasks anywhere where you're going to be moving between multiple resolutions in a document. So something like map navigation, where you start it at a high level, relatively high level, and then zoom in to look at a detail, or like a photo manipulation task where you're going from a low level of detail on a photo back out again. Even something like PDF viewing or document viewing, where you might go from, say, a thumbnail view down to viewing a paragraph to do an annotation or something like this. Okay, these are all examples of I think, fairly common pinch to use tasks where you tend to use pinch to zoom and pan together. So this is just an example of what a sort of a standard pinch to zoom interaction looks like using a text document. So in this case, the user is actually, they've got a view of a PDF, they want to drill down into it and just do some kind of an annotation, underline a word, highlight something that's important. And it's interesting to watch people do this because there's a little bit of a pattern that emerges if you watch it for a few seconds. And you can see how they start at one resolution, make a decision to do something, and then zoom to get to a target that they can actually work with, or a resolution that they can work with. They perform an action, and then they bounce back out again. And this is a really common pattern that we see repeated over and over again when people are performing sort of these pinch to zoom manipulations on a document. So we really think of it as three steps. There's sort of an initial step where somebody makes a decision to do something with this, and they zoom in on that area of interest. For the second step, they perform some task, right? Whether it's red eye reduction on a photo or underlining a word or something like that. And these are fairly straightforward. We don't see a lot of obvious room for optimization there. But there's this last step. This last thing that happens is where they bounce back out again from the task that they just performed, okay? And typically what they're trying to do is return to the resolution they were at prior to performing that manipulation. So this is really what we're going to focus on for this research. It seems like a small thing, but we think it's a small thing that could have a significant impact, because this represents quite a large amount of work for that task. So if we can eliminate that work or optimize that work, we can save users a considerable amount of effort. So I need to acknowledge there's a lot of prior work in this area, right? And there's a lot more than just this. I'm not going to dwell a lot on this, but I just want to acknowledge that there's been a number of attempts to sort of replace pinch to zoom or come up with sort of better versions of pinch to zoom. And for reasons that we'll get into, we're not actually going to try to do that with this research. Instead, we really wanted to look at this mechanism, this sort of bounce back or snapback mechanism. And we were motivated a little bit by two papers in particular. Negulescu's zoom pointing from 2011 introduces this idea of this sort of transient snapback from a zoom. It's a little bit more constrained in the way he does it, but it's certainly a valuable approach that we wanted to sort of leverage. There's something very similar in Appert's reciprocal drag and drop. There's sort of this notion of transient movement as well of a view. So we're going to leverage that in our design. So before I get to the design, we're almost there. We just need to sort of think about the context. This is a step that's easy to miss. One thing that we recognize in all of our gestural research is that you can't really make modifications to gestures in isolation. Gestures exist as sets that work together for a particular task in a particular application. So it's important to consider the context that you're working in. So our context is this notion of an overview and detail application, like photo manipulation or map navigation. And we really categorize sort of the common gestures into two sets. The first is this idea of content interaction gestures, the ones at the top. These are things that let you change the content. Tap to select something in the image, or slide to drag to actually manipulate something in the image itself, press for a context menu. Okay, these are actually manipulating the content that you're looking at. Now there's the second set of gestures, which includes pinch to zoom, and these are gestures that are really intended to manipulate your view of the content. So they don't change the content, they just manipulate how you see the content, and they allow you to do things like change resolution. So again, that includes pinch to zoom, spread to zoom out, two-fingered slide to pan. It's often done as a two-finger gesture to disambiguate from the single finger swipe. And it also includes this sort of slightly more novel gesture, this notion of double tap to zoom, which is something that's a relatively recent introduction. This is the idea that you can actually use a single finger to perform a zoom operation instead of pinching or spreading. You see this on lots of smartphone applications, for instance. What makes the double tap to zoom a little bit unusual is that it's heavily dependent on the designer of the application to decide what the characteristics are for the zoom, right? So you double tap, and the designer has to determine the appropriate zoom level for that application in that context. So the user doesn't have as much control, but in some scenarios it's considerably faster. So we'll consider that as well. Okay, so we have this gesture set. We want to do something to add this transient snapback functionality. So how are we going to do that? Well, that's our objective, right, is to introduce snapback. But we're going to do it with these three design goals in mind. The first one is that we want to extend instead of replacing gestures. So we do not want to write a better pinch to zoom or a better pan gesture. Part of the challenge in doing any sort of gesture design research right now is that these are very firmly entrenched ways for people to interact with devices. It's going to be very, very difficult to convince people to sort of give up pinch to zoom the way they're accustomed to it. They're very familiar with it. And secondly, in a lot of contexts, the gestures we have are perfectly fine. It's really certain specific scenarios, maybe expert user scenarios even, where we want to offer this additional functionality. So we want to extend the gesture set. Secondly, we want to leverage semantic meanings of existing gestures. Well, what does this mean? It means the gesture should make sense. It should feel like it belongs. It should be a natural extension of the gestures that you already have and that you're already supporting for your application. And our last principle is this idea of keeping users in control. Users love things to be explicit, right? They want to actually have control over what they're doing. They want to feel like they can sort of dictate when this transition happens or doesn't happen, instead of doing it automatically for the users. So we're going to try to attempt to do that as well. So here you go. Here's what it looks like. So what we did is we leveraged a bookmarking metaphor for our transient zoom and transient pan operations. So the way it works is you put an additional finger from your non-dominant hand down on the screen. That's the finger that's marked with a little blue circle. That's just an indicator to let you know you're in that mode. And then you can perform any other operation you want that would normally be supported, like a zoom or a pan or an annotation, doesn't matter. But when you release that secondary finger, it snaps back to that resolution. All right, in other words, we save the view state at the time you put that finger down, and we allow you to restore that view state at a later time by just lifting your fingers from the screen. So one way to think about this, the way we talk about it in the paper, is it's a quasi-mode. It's very much akin to like a control key on a keyboard, right? It doesn't replace the existing keys, it just lets you augment them and change their meaning in a specific context. And that's what we're doing here. Okay, this is a little bit of a more formal description of it. This is in the paper as well. Just to kind of quickly run through it, you're starting with figure A. Figure B, you can see the user putting down their two fingers to start a zoom operation. They put down a third finger as well to flag it as a transient operation. And figure B's view state is what's saved at this point. Figure C and D, they perform a zoom, they underline the text, they do whatever else they want to do. Figure E, when they release their fingers from the screen, again, we snap back to that starting resolution. And then from that point on, they can do anything else they want. Any other operations they want. So that's it. So the question is, how well does it work? Our primary goals were to sort of beat standard pan and pinch to zoom in performance, and we would like to compare to those gestures. So we want to compare ourselves against standard pan and pinch to zoom. We also want to compare against this double tap to zoom or this contextual zoom that I talked about earlier, and we don't think we can beat it, because if you think back about how that works, the contextual zoom is really, in a sense, the perfect zoom. In an ideal scenario, if the designer's expectations for what you want to do and your expectations line up perfectly, then when you double tap, you get this perfect zoom that occurs. So it's possible that double tap to zoom could be kind of the perfect zoom in the right situation. So we're going to compare ourselves to that as well. Again, not because we think we can beat it, but we sort of see it as a gold standard, and we're kind of curious how close we can get to it. And again, we'll focus on overview and detail tasks like the ones we've been discussing. All right, so this is our experimental task. This is sort of the overview level of our application. This is a high-level view of what you would see on the screen of a tablet. This was all conducted on an Android tablet. And the screen consists of 12 cells labeled A through L. And within each cell, there's tiny little bits of text that you can't see without zooming in. So it's literally impossible to read what's in those boxes without zooming in to look at the details. Within each cell, you have row 1 through 9, and then a randomized letter beside it. And again, every cell is different, has a different random distribution of letters. And then one of the cells is flagged as a starting cell. Okay, within the starting cell, you have a single row with a letter and number, which is actually telling you the target cell that you have to go to. So I'm gonna walk through this, and I think it makes a little more sense if I kind of go through it in steps. So the user would launch the application, they'd be given their first task, they would see something like this full screen, all right? That little starting block would fill the screen, and they would see, in this case, J2. That's telling them that they need to go to cell J, row 2, and find the value that's there. So they navigate out, which is like zooming out, locate the next cell, cell J, go to J, look up row 2, find the value E, go back out again, and then go back to their starting cell, and then write that value down. Okay? So this is intended to, be similar to any kind of task, again, where you're jumping between these resolutions. And our hope for our transient technique is that we're eliminating that last step. So we're hoping that by eliminating sort of the last overview step and jumping directly from the target back to the starting cell, we'll save a considerable amount of time and work. So this is what it looks like. Quick little video clip. Again, you can see the little blue circle indicating it's in transient. Starting cell back out, back in, and when they lift their finger, they bounce back out again to the starting cell, okay? So it's considerably faster for that last, the last maneuver. So in our evaluation, we had the following hypotheses. We hypothesized that the starting cell position, which we're going to randomize, is meaningless, all right? It's just a bit of noise. That it doesn't really matter where you start and where you're going to see similar performance. And in terms of comparative performance between techniques, we expect, in terms of number of actions, which we see as sort of the amount of work that you have to perform, we expect transient to be the best, to require the fewest number of actions to perform, followed by double tap, and then standard as being the largest consumer of actions. In terms of time to complete, we expect that double tap will probably be the fastest technique. And again, the way we implemented it was the perfect double tap to zoom, all right? We actually implemented the perfect zoom in this situation to compare ourselves against that. Our study design, it was within participants, so every participant ran every condition. Our blocks consisted of 3 techniques and 12 starting positions, so 36 tasks per block, repeated times 4 blocks, so that's 144 tasks per participant. Ran 18 participants for a total of 2,592 tasks. Quickly running through that. So this is what we get for results if we're looking at time. So as you would expect with any kind of novel technique, there's a learning effect over the 4 blocks across all of the techniques. So we just focused our analysis on the last block of the technique. And it turns out the technique does affect task duration significantly. As you can see in the chart, normal is the slowest, double tap and transient are both significantly faster than standard. So in terms of time, sort of standard pan and pinch zoom is about 5.3 seconds. Double tap is 4.7 for the perfect double tap, and transient is 4.4, which is 17.3% faster than the standard pan and pinch to zoom. And we were we were pleased by this result. We were a little bit surprised by this result as well, because we honestly thought that the double tap was going to be faster, but we ended up being comparable in terms of performance. And then the second thing we looked at was the amount of work, which is the zoom count and pan count, or the number of actions that were required. It turns out that there is no impact of technique on pan count, which sort of makes sense if you think about the task. There isn't really any panning required for this task. We didn't prohibit it, but if you think about what users had to do, they could target where they needed to go very precisely without panning around the screen. So we're not really surprised by that. But technique did impact the number of zoom actions required, which we expected. So sort of standard gestures were about 3.4 zooms to accomplish. Double tap was fixed at 4.0, and transient zoom was 1.43. The reason double tap was fixed at 4.0, because I think people are going to ask me this, is that, again, the way it was implemented, you double tap to transition between screens. There were 4 transitions, 4 double taps would do it, right? So there was really not a lot of variance there. In terms of the gain here, we're looking at about 57.6% fewer zooms for transient compared to standard pan and pinch to zoom, or about 64.4% fewer than double tap. So that's a significant reduction in the amount of work. And the last thing we did is we ran a short survey afterwards, asking people to, on a 5-point Likert scale, to rate the techniques based on ease of use, effectiveness. We asked them to rank it as well, that I'm not going to get into. And as you can see, double tap and transient were both comparable in terms of ease of use and effectiveness, and both significantly better than standard pan and pinch to zoom. So users liked it. They liked it quite a bit. A few comments just to sort of give you a feel for the sort of feedback we got, the sort of open-ended feedback. I thought transient gesture made a lot of sense because it was built on standard gestures that I already knew how to use. This was participant 1. This sort of directly supported our choice to augment rather than replace, right? And so this was pleasing. We didn't want to have to bring in new gestures. We really liked the idea of leveraging what we already had, and we think that helped made the techniques more learnable as well. Participant 3, our last comment, when I got used to it, I missed the bookmark when I didn't have it. It felt like a normal extension of that technique. And this supports our notion of leveraging semantic meanings. So. All right, just to sort of wrap up a little bit, what's next for this research? There's always issues of occlusion. I just want to mention this because it's something we're sort of thinking about for next steps. Anytime you deal with direct manipulation in touch, occlusion is always an issue. Potentially introducing a third finger means you're introducing more occlusion. It can be argued. One thing you will have noticed in the technique is we supported this ability of the user to slide their finger around. As long as you kept it on the screen, you could actually move it out of the way. So we feel that over time, they can learn to sort of activate on the sides of the screen, and probably occlusion is less of an issue. The other thing we really wanted to address long-term is this idea of dealing with larger real-world tasks. I think our experimental task is quite representative of a lot of tasks that you're going to see. But when you get into, say, longer sessions, like a long strategy gaming session or a long photo manipulation session, we'd be really curious to see sort of the long-term effects of trying to use this technique as well. So to wrap up, we've introduced transient gestures, which augment standard pan and pinch to zoom for multi-resolution tasks. I think we've demonstrated better performance for transient versus standard pan and pinch to zoom, and we believe our technique is more flexible than double tap or contextual zoom. Thank you very much.
Hi, I'm Micha from Northeastern University. Great work.
Thank you.
One question is maybe an easy one. It feels like this technique is not that bound to pinching in particular, and it feels like it could be used for anything. And for example, also for the double tap, you could like have one finger while you're tapping with the other one. How do you expect that to work out?
You absolutely could. Yeah, basically any view manipulation you wanted to perform, you could definitely do. We actually implemented it with transient double tap, with transient tap and a half. We just didn't test those experimentally, but yeah, you can certainly support any view manipulation through that as well.
Cool, thanks.
Thank you.
Hey Jeff, from Preferred Networks. I was wondering, this seems very similar to spring-loaded modes. That paper from Ken Hickley et al. I think Kai 2006. So I wonder how it differs from that technique where you basically maintain a finger down a menu selection, and then you perform your transient operation, and then you just release the finger to come back to the previous mode. So that's pretty much what you're doing, but you're focus on, I don't know, pinch zoom. But
I am, yeah. Now you're putting me on the spot because I don't remember exactly that work. Although I've cited it. So
springboard.
Springboard. I'm sorry, off the top of my head, I can't think of the difference. Let's talk about it offline.
Yeah. Okay.
Let me pull my notes out.
Sorry about that, Jeff.
Yeah, it's okay. Thanks. Appreciate it.
So I have one question. Like we have used a within subject study.
Yes.
So I'm wondering, because there are a lot of gestures and also maybe users having some learning effect on that. So it could be between subject would be the better choice on this kind of.
Our concern is that individual performance varies so much. I'm always very, very reluctant to do between subject with this kind of research, because you have to run such an exhaustive number of participants to get a feel for it. It was a bit of a balancing act. We also didn't have an incredibly long experiment because we didn't want fatigue effects either. But I think we did a reasonably good job. We had fairly consistent performance within users, so I think it was a reasonable choice.
So how much time for each user?
It was
to having
about 40 minutes, I believe,
Okay.
30 to 40.
Okay, got it. Maybe later we can talk on this.
Yeah, please.
Yeah.
I'd like that.
Thanks again.
Okay.